Hi there! The Darkglass Anagram has been out for a couple of months now, so let's talk detail about the open source amplifier and pedal profiles at the heart of it, aka neural amp modeling. My name is Paajanen and we are currently in my home studio, and in this video we will go over what neural amp modeling is, how it compares to the other profiling solutions on the market, how to create your own amplifier models, and how to use them inside the Anagram. Let's get right into it. Neural Amp Modeler is an open source project created by Steve Atkinson, which enables anyone to create the most accurate amplifier and pedal models on the market with very lax hardware requirements. After running this very specific profiling audio clip through your gear and recording the results, you then run both of those files through a program created by the NAM team. That program then uses machine learning powered by multi-layered neural networks to create a single profile file that contains the tone and the response of your gear as it was at that specific moment. If any of that went right over your head, don't worry, as we will be doing a step-by-step guide on how to create your own NAM profiles at the end of the video. At the time of recording, NAM is also the most accurate way of profiling audio equipment on the market. There are a lot of other solutions for profiling gear on the market, but when it comes to the mathematics behind the amplifier and pedal profiles, NAM is by far the best. If you're wondering what math has to do with your sick bass tones, well, that is in a sense everything that digital signal processing is. We turn our incoming signal into ones and zeros by using an analog to digital converter, and then we run those numbers into our computer, in this case the Anagram. A profile file in its simplest form is just a table that contains information on how to treat the incoming numbers, and then we do that math like a billion times a second or so, and boom! From a boring old DI to a sick-ass bass tone. Of course, all that math doesn't come for free, and due to the extremely accurate nature of NAM, running those profiles can be very taxing unless you convert them to a simpler format, which is what most multi-effect modelers do. To run NAM effectively in its native form would require some very specialized hardware. Perhaps something like what we have in the Anagram. The Anagram can currently run up to 3 simultaneous NAM profiles within a single preset, and the Darkglass team has plans to expand on that without sacrificing the quality. So, how do you get more of these NAM profiles than currently exists inside the Anagram? The easiest way to go would be to go to an online profile sharing platform such as Tone 3000 and search for those. If you have some pedals or amplifiers or plugins that you'd like to capture yourself, that's a good option too, so let's go over how that works. Currently there are 2 main ways to capture your profiles, and those mainly differ in what we are feeding our gear to create the profile. The first method is the one proposed by the NAM creators, and this method gives us the most accurate and universal results. In this method we take the input.wav file that NAM provides us and feed that into our gear. This file contains all kinds of pops and squeeze and tweets and sweeps, and will run the full audible frequency range and its full dynamics through your gear, providing us with the most detail on how that gear sounds and behaves. The second method is much simpler and easier to achieve, and this is the dry and wet method provided to us by the folks at Tone 3000. This method uses a modified neural trainer which allows us to play through our gear for 1 to 3 minutes while recording both the dry DI and the affected signal, and then using those to create our profile. This method can be accurate when making profiles for your personal use, But since the training depends on the material that you played, it requires some special care during the recording that might not make it that universal. See, everything the final profile knows must come from the training material. Unless we include the extreme ends of our frequency range and our dynamic range, the final profile doesn't know how to react when it encounters those extreme ends of the spectrum. If you're interested in profiling your own gear, the dry and wet method is a good place to start from. Just remember that when making the initial training data, do all kinds of stuff. Play with your fingers, play all across the fretboard, slap some, pick some, and don't forget the chords. Before you go wild profiling your own gear and make 100 orders from your local web store with free returns, it's important to know what we can and can't capture on a NAM profile. First and foremost are any and all time-based effects. No deal. So any effect that changes over time, such as delays, reverbs, modulations, choruses, flangers, will most likely result in an incomprehensible profile. This generally includes compression as well, or kind of. You can capture signal change with compressors in it, and it will probably even sound pretty neat. The profile can't capture the changes in dynamics that the compressor applies to the signal, since that is a time-based process as well. But it's a good idea to try anyway, because some compressors, or perhaps most compressors in the guitar world, have a sonic character of their own that they impart to the signal, and that should come across pretty well in the final profile. Now, for stuff that you can capture, the list includes all of these and probably also a lot of things that I forgot to mention. You can capture amplifiers, overdrives, distortions, fuzzies, EQs, bass preamps, microphone preamps, cabinets, analog effects, solid-state amplifiers, digital effects, and even plugins, provided that those plugins do not contain any of the effects that we talked earlier. Since the Anagram can already run up to 3 different profiles simultaneously inside a single preset, we can split even complex rigs to their parts and then use those parts separately as separate profiles inside a single NAM preset, and maybe even add some processing in between. So, what can you change in a profile? When you load your NAM profile into the Anagram or pretty much any NAM loader, they usually give you some controls, such as inputs and outputs and perhaps even an EQ. It's important to note that none of these controls directly correlate to the controls on the captured gear. The profile itself is static. It doesn't change with temperature or with the voltage supplied, nor does it need its tubes changed. The only things we can change after the capturing process is how loud the signal goes into the profile and what frequencies and how much goes into the profile, which is surprisingly useful. One of the key things to how different distortions sound is how they filter the signal between different gain stages. And having the access to all the graphic EQs and the semi-parametric EQ inside the NAM loader block inside the Anagram can yield surprisingly versatile results. So, now that we know everything there is to know about these profiles, let's create some of our own. I have here with me all the pedals that I use to create my bass tones, and we will try both of the methods outlined earlier in the video to capture these and to see how it works. The signal chain we are working with is the following. First, we run into the Darkglass Supersymmetry compressor. I have done captures with this compressor on before and it works fine. But today we are going to turn the compression knob all the way down to 0. Why? because in addition to the compression, this pedal also has a slight low-pass filter inside it, which helps us control our high end from becoming too fizzy. Up next, we have the Ground King FX PN7, a pedal that I created together with Ground King FX to bring my favorite bass boost pedal back into production. After that, we run into the way huge Pork and Pickle bass overdrive and fuzz, and then we finish things off with the Darkglass B7K. There are a couple of ways that we could approach capturing this. We could capture the whole thing as one profile with all the different gain stages, since NAMM can handle even those complex interactions very well, or we could capture our boost circuits separate from the B7K, since the Anagram already has the B3K distortion block inside it. I guess we can do both and see where we end up. One important thing to remember before your recording session is to set your recording session to 48 kHz, sample rate, 24-bit bit depth, and the recordings to mono. Then we are ready to proceed. First up, the easier and simpler method, the wet and dry method with Tone 3000. This method is super easy to work with. All you need is the gear that you want to capture, a splitter and an audio interface with 2 inputs. Or we could just use the Anagram as both our splitter and the audio interface, since it also functions as a 3-in 9-out audio interface. This method is very easy to use within the Anagram, as all the processing both inside the Anagram and at the FX loops are very carefully gain matched to work at unity gain levels. That makes it easy for us to connect into the Anagram and split our signal so that we get both the clean signal and the effects that we want to capture. We can achieve that by sending the signal from our Anagram into the gear that we want to capture by using the FX loop send. If we are using an external audio interface, we can then connect the signal from the Anagram and from our captured gear into that audio interface as usual. If we are using the Anagram as our audio interface, we will need to get the signal back into the Anagram from the captured gear, and we can use the FX loop return for this. We can then record the input 1 from the Anagram, which is the signal before it hits any kind of processing, and the input 2, which is the left channel of the signal after all the processing. Now all we have to do is tweak our gear to get a sound that we'd like to capture, and then play through the gear with as much dynamics and range as possible. Phew, let's get into it. Now that we have our files and they are both the exact same length, we can upload those to the Tone 3000 website and create our profile. The Tone 3000 trainer will use these files to train the neural networks through 100 epochs, and which is more than enough for our purposes, but it will take some time. So let's do the Reamp method in the meanwhile. For the Reamp method, you can either use a standard audio interface and connect the outputs to a Reamp box, or you can just use the Anagram as your audio interface, which will make the whole process a lot easier. Simply drop the input file provided by NAMM into your DAW, and then route that file into the output 9, which is the virtual Reamp input inside the Anagram. Then you can route the signal out from your Anagram into your gear by using the FX loop. Very easy. At this point, it might be a good idea to check the tone that we are going to capture, as well as check the levels on which the capture file is getting played through the Anagram into our gear. Ideally, we would like the capture signal to be routed into our gear as loud or slightly louder than our bass signal is going into the gear, so that the capture will sound just like it did when we dialed it in. We can easily see how these two volumes compare by recording a short clip of our playing into our DAW and then comparing these two. Ideally, these clips should have the same volume, which usually means lowering the output from our capture signal by a little bit. Now that our signals have been gain matched and the tone we are recording matches our vision, we can start reamping. This process will take around a minute, but you probably will want to keep your monitors turned off during it, since those pops and squeeze tend to get a bit annoying after a while. After our files have been recorded, we will need to check that the output file matches the length of the original file exactly to a sample level. Luckily, the original file syncs up to a 120 BPM session very nicely, so it's easy to trim our recording to be the same length. Then we upload both of these files into the Tone 3000 service and wait for them to be processed. Now, if you don't want to use the Tone 3000 service, you can also use the Google Collab and take advantage of the GPUs that Google hosts. Go to neuralampmodeler.com, click the Users section and click Get Started Online. This will take us into a Google Collab session where we can process our captures into profiles. First, we will need to set our runtime to take advantage of the Google GPUs, and that is done by clicking the runtime menu in the upper left. Select Change the runtime type and select the T4 GPU, which is the free GPU Google offers for its Collab users. From here on, you will need to upload the input file as well as the output file from your recording session and label them as the input.wav and the output.wav respectively. Click on the folder icon in the left row to see the data in your session and upload those input and output files into the root folder that opens up, not into the sample data folder. Then we can set up the training methods. These default settings are already very good, but the model also offers some more lightweight options for the training process that unfortunately also decrease the accuracy as well. I would stick to the 100 epochs training time, as that has proven to be the best compromise between training time and the accuracy of our results. You can fill in the metadata as well, but that is an optional step, and as far as I know, most modelers don't really use this metadata at all. This metadata doesn't affect our training process in any way. When all of this is done, you can hit the play button in the upper left, right next to the training parameters, and the program will start scratching its head to make some sense of the files you have offered it. At this point, it might return some errors if there's anything wrong with the files that you have offered it. So be sure to upload the original input file as provided by the NAM team, as well as making sure that your recording is exactly as long as the original input file, since the process will fail if the other file is even one sample length off. And that is the process in a nutshell. In the end, you will be left with a .nam file that you can then upload into your favorite modeler and enjoy the sound of your gear wherever you go. I have partnered with Darkglass Electronics to offer you a small sampler of the tones that I personally use a lot through NAM captures that will be available as part of the Anagram factory library starting from the next patch. This profile pack includes some of the captures that we just made by using the whole pedal array, as well as just the boost section on its own, so that you can better utilize them to create your own tones. I have also added some of my favorite clean tones into the mix for more versatility. That's all that we've got for now. I have been and will continue to be Paajanen, and this has been the Darkglass Anagram and NAM Quick Dive. Thank you for watching, and I'll see you around.